Okay, radians and area of a sector and length of an arc came up in C2 in the old spec. So the next question we'll look at is 2018 C2, and it's question 7 at the back. And just run through the question. First of all, you can see here they've got two pictures going on. It's talking about the hat. So can you see the hat is this top segment? I'm going to draw it and let's see if we can focus in on what they're talking about as the hat. So this is not A, B. This line across here, this is the radius. That's going to be the radius as well. This angle is theta. This bit here is the hat. Okay. The question is asking, find in terms of r and theta the area of the hat. Now, how do we get the hat? So the area of the hat is basically the sector area, okay, the whole thing, so that's not AB. Take away the triangle, and that will leave you with the hat. So that's R, and theta. So the area of the hat sector is a half r squared theta. Area of a triangle is a half AB sine C. So I'll just write that out here at the side. So it's a half AB sine C, that's the angle between them. So in our case, it's a half r times sine the angle between them. So r times r is r squared times sine the angle between them. Now, if you look at the question, it says, find in terms of r and theta. I have found in terms of r and theta the area of the hat. So that's it, finished. So don't be scared if they're using algebra instead of real numbers. Part 2 says, in the model, the area of his face is m times the area of his hat. So I'll write that down first of all. So area of face equals m times area of hat. Now you have the hat worked out, so let's get that mark secured. So m times the area of a hat from above there. Now if I go back to the original picture, I want to see what his face is. Now if you see his face there, it's the circle, take away the hat. So the area of his face is the circle minus the hat. Area of any circle is pi r squared. It's come from GCSE. Take away his hat. His hat's still up there. Should put a box around it to make it easy to find. So take away his hat. Half r squared theta minus half r squared sine theta equals all of this. I might as well take this m through at this stage. Half m r squared theta minus a half m r squared sine theta. There's a lot of halves, so I'm going to multiply everything by 2 just to make that a wee bit easier. So 2 pi r squared minus r squared theta. That becomes plus r squared sine theta equals, remember still multiplying everything by 2, so it's m r squared theta minus m r squared sine theta. I notice there's an r squared in everything, so I can divide everything by r squared. 2 pi minus theta plus sine theta equals m theta minus m sine theta. I'm just going to check the question to see what way they want the answer left. They say find m in terms of theta and pi. So they want m on its own. So if you look here, all my m's are on that side. So what I'm going to do is just going to factorise out the m. So m theta minus sine theta. Bring that bracket over to the other side. And now I have an expression of m in terms of pi and theta. And I'll just write it the other way around just to make it nice and neat at the end. And that is that question finished.